You did like what you did. You read it, you put it into the calculator and read it. Oh yeah, you just write it back to the paper and then you can calculate and you can answer that way. You don't have to do what it looks like. Also makes it easier to double check stuff.
My apologies again to the online people. There it is. It just popped up here. Excellent. So it looks like we're on our way today. Page 301. What's that mess I have up there? In problems 1 through 20, classify each number as rational or irrational. Page 259 defines rational numbers. Page 296 defines irrational numbers. Let me change to red here. Are you familiar with numbers like this? Can anyone read what that says?
Square root of 121.
Thank you. The square root of 121. And if you take your calculator and you punch in 121 and then hit the square root button on your calculator, what do you get for an answer? 11. That's problem number 2. Problem number 4, can someone read that? The square root of 169. You punch that in your calculator, and what do you get? 13. Now, is 13 a rational number? Based on page 259? Yes. Is 11 a rational number? Yes. So, watch what I did here. Between 2 and 4, I came up with another number. The square root of 144 is, put 144 in there and hit the square root button, and what do you get? 12. So that's a rational number. Now, here's the square root of 121. What's the square root of 122? Hit your calculator, put 122 and hit square root, and what do you get? You get some kind of big long decimal, right? So guess what? That's irrational. If you do 123, same thing. That's irrational. The square root of 122 is irrational. The square root of 123 is irrational. The square root of 124 is irrational. The square root of 125 is irrational. Have you figured out what's going to happen? All the numbers between the square root of 121 and the square root of 144 are irrational numbers. The square root of 143 is irrational. So, do you understand when it comes to these square root numbers, how you basically can make a list of all the rational square root numbers, and all the square root numbers in between those rational numbers are automatically irrational. Does that help when you're working with these square root signs? Does everyone understand what I just said? That you've got 11 is the square root of 121. 12 is the square root of 144. The square root of all the numbers between 121 and 144 are irrational numbers. And 12 is the square root of 144, so that's rational. 13 is the square root of 169, that's rational. All the radical numbers, all the square root numbers between 144 and 169 are irrational numbers. And if you make a note of that, then you should be on your way to making sense, to kind of getting a big picture understanding of what's going on here with these square root signs. And you're going to hear me refer to square root signs as radicals, because that's the mathematical name we use for them. We call it the square root of 121 is 11, but it's also read radical 121. And does everyone understand that the square root of a number means what number times itself would equal 121? And of course 11 times 11 is 121, so that's why 11 is the square root of 121. Okay? Questions? Then let's jump down and do number 6. The square root of 9 is what? What number would you take times itself to get 9? 3, which is a rational number. The square root of 15. Now watch. The square root of 15, do I have that down here somewhere? Did I put it down here? No. Did I put it out here? Okay, let's put the square root of 15 right out here. And in front of the square root of 15 is the square root of 9, because that's 3. After the square root of 15 is the square root of 16, because that's 4. And both of those are rational. So what does that make the square root of 15? It's between the square root of 9 and the square root of 16, so it's an irrational number. And if you put 15 in your calculator and hit the square root button, you'll get a decimal that doesn't repeat and that doesn't terminate. But since your little calculator screen only goes out maybe 7 or 8 places, you won't realize that. If you had a screen that would go out 15 places, do you understand? You would go far enough to realize that it doesn't terminate and it doesn't repeat. There's a way to check this out. You say, how do I know this just keeps going? Well, when you hit the square root of 15 is 3.8729835. No, 833. If you went ahead and typed in, if you took 3.8729833 and hit times 3.8729833, you won't get 15. You'll get something close to it, but that's why it's not a rational number. It doesn't come out exactly that. It's an approximation. And that's how you can check these things with your calculator to see if you've got an approximation or the real thing. So number 6, is it rational or irrational? If it has a rational numerator and an irrational denominator, that makes it an irrational number. If any part of it is irrational, the number is irrational. If any part of the fraction is irrational, it's an irrational number. Number 8. Does number 8 say negative 22 over 7? Is that the same as negative 3 and 1/7? So I take 1 and divide it by 7, and I get this big old long number here, if I have a calculator that goes that far, and do you see a pattern? Hey, 142857, 142857, 142857. So it repeats. So if this pattern repeats, what does that make this number? Is this number rational or irrational? Page 296. What does page 296 say? It's irrational if what? Non-repeating or non-terminating. Does this one terminate? No, because of the 3 dots. Does it repeat? Yes. So if it repeats, then what does that make it? A rational number. It might be that you want to put in your notes, instead of saying irrational numbers are non-repeating and non-terminating, you simply say rational numbers are repeating and are terminating. And if it doesn't repeat and it doesn't terminate, then it's irrational. You follow? Maybe this, looking at it from a negative standpoint, is puzzling to you. So just write it in a positive fashion, that rational numbers either terminate or repeat. And since this one repeats, that makes it rational. This part right here just repeats over and over and over again. So that makes it a rational number. Okay? Number 10. Is -0 rational or irrational? Well, there's really just 0, isn't there? I mean, there's no negative, positive, just 0. Is 0 a rational number based on the definition on page 259? Yes. It's an integer. It's a rational number. Number 12. Now look at number 12 carefully. Does number 12 terminate? That's a yes or no question. Does number 12 terminate?
No.
No, because of those 3 dots. Everybody follow that? Does number 12 repeat? Now, do you see a pattern in number 12? In other words, could I come over here and say, hey, I know what to write next. This was 023, 0023, 00023. That means it'll be 0, 0, 0, 023. Everybody follow what I'm doing? Dot, dot, dot. So now, I see a pattern, but here's the question. Does the pattern repeat itself? In other words, does it have to be 023, 023, 023? You follow me? It has to be the same thing that repeats over and over and over again. Does this number repeat the same thing over and over and over again? No. So it doesn't repeat and it doesn't terminate. So what does that make it? An irrational number. To be rational, it either terminates or it repeats. So sometimes the guy in the book is going to make it look like, well, he's going to show one with a pattern, but it's still irrational because it doesn't terminate and it doesn't repeat. It doesn't repeat the same pattern over and over and over again. Any questions? Everybody follow that one? Then let's jump down here to number 14. Here's the number. Is that rational or irrational? 0.121231234. See, here's what they're doing to catch you. Are there 3 dots at the end of it? No. So what does that mean? It terminates. If it terminates, what does that make it? A rational number. You got to write yourself some notes, don't you? This is going to be a little tricky. Your eyes are going to deceive you. But did any of you ever walk down, do you ever see railroad tracks where it looked like if you look far enough down the road, the tracks come together into a point? Did anyone ever walk down those railroad tracks trying to find that point where they come together? They don't. Your eyes are deceiving you. And if your eyes didn't deceive you, you wouldn't have depth perception. So we get used to it with a lot of things, but then it seems that when it comes to math, our eyes deceive us and we get all bent out of shape about it. Just accept it. Number 16. Now you see what I did with number 16? I just broke it out into 2 parts. The square root of 25. What's the square root of 25? 5. What's the square root of 4? 2. Are 5 and 2 rational numbers? Then that makes this a rational number. Everybody follow that? Number 18. 0.1122334455. Is that a rational number? Yes, because why? It terminates. There you go. You're starting to see it. It terminates. That's a rational number. Number 20. Can anyone tell me what number that is? Pi. Does anyone know how we discovered that number? Well, let me turn over here. Here's a circle, and here's the diameter of the circle. So I take the circumference of the circle, and I divide it by the diameter. Then I draw another circle. And I draw the diameter. And I measure the circumference of the circle. I take a tape measure, a piece of string, and I measure around the outside. Then I measure the diameter. And then I divide those. Then I take another circle. There's the diameter. I take the circumference. I divide it by the diameter. Does anyone know what I get every time I do that? And whoever discovered that goes, wow. And I guess they discovered that because they were messing with pieces of pie or with pies. So somebody decided the Greek letter pi would be the one to use for this marvelous little fact here. Now, if you try this in real life, if you could get a bunch of cardboard circles and measure around them and then measure across, do you understand that your measurement might not be exactly right? So it's not going to come out exactly 3.14 every time. It's going to come close to it. But if you had exact measurements, it always comes out to be this irrational number. Whoops, I just told you what it was. Because, see, it's approximately 3.14, but does anyone know what comes after 3.14? Google pi and see how many places they have for it. There's a whole bunch of them. And no matter how far out you work pi, it doesn't terminate and it doesn't repeat. So that makes pi an irrational number. Any questions? Are we having fun yet? Questions 21 through 32. Evaluate. How do you evaluate 49 with a square root sign? How do you evaluate radical 49? You put 49 in your calculator, hit the square root sign, and you get 7. How do you evaluate negative 144? You put 144 in your calculator, hit the square root sign, and you get 12, but since there's a negative there, it's a negative 12. Everybody follow that? What do you do with radical 256? I don't know. Move it up there. You punch in 256, hit the square root sign, and you get 16. You understand how we're getting all these answers? (33 to 34). 33 to 46. Put this or this or this in between the two numbers. So let's just erase that for a minute. So what is this? How do you read this first symbol? Less than. How do you read the second one? Greater than. And how do you read this one? Equal to. So is 17 less than, greater than, or equal to 11? Greater than. Everybody see how it works? See what's going on? Let me put it up higher. There. Everybody see what's going on? So number 36 says 12 over 19 and 11 over 17. Whoa. Well, my common denominator would be 19 times 17. 19 times 17. So I have to take 17 times 12 times 17 times 17. And then over here I have to take times 19 times 19. And what do I end up with? 204 here and 209 here. So what goes in between? Less than, greater than, or equal to? Less than. Everybody follow that? Now what's the other way you could work this? Take your calculator, hit 12, and then do what? Divide by 19, and what do you get for a number? What?
0.631575.
Now take 11 and divide it by 17. And what do you get?
0.647.
0.647?
05.
05. Now look at these two numbers. Which one is this number greater than this one, less than this one, or equal to it? And all you have to look at is these first three digits. Is 0.631 less than 0.647? 0.631 over 1,000 is less than 647 over 1,000. Everybody follow what's going on? So you could get to the answer that way as well. I just like fractions. They're some of my favorite numbers. I think I like them because so many people don't. So I like to befriend the people in life who others seem to reject. And fractions just don't get a break, so I've made them my friends. Plus, I think they're kind of cute. And I've never seen a cute decimal in my life. I know. It's just a judgmental thing in a man's, in your own mind and preferences. You guys don't give beauty to mathematics like I do? Okay, number 38. Well, 1 2/3. Now 38 says 1 2/3. Whoops, let's go to red. It says 1 2/3. But 1 is 3/3, isn't it? And 3/3 and 2/3 would be 5/3. Okay? So that's where I get the 5/3. And then, what is else 38 says? And it says 8/6. So I've got 5/3 and 8/6. Well, I'll just use 6 for a denominator. And that means this would be times 2. That would be 10 of these. And then 8 of these. So what would that be? Is 10/6 less than, equal to, or greater than 8/6? Greater than. And again, if you took 5 and divided by 3, what did you get? 1.666, right? And if you took 8 and divided by 6, what do you get? 1.3. Tell me what you got. Say, I don't need to. I've gone far enough to know that this number is greater than that one. You follow me? Okay. Questions? Number 40. 3.777 ... Don't forget those dots. Be sure and notice them there. And the square root of 15. Well, punch in 15, hit the square root sign, and this is what you get. So, which is greater? 3.777 is less than, greater than, or equal to 3.87. Less than. See how I just look far enough? I just go down far enough to see which one's going to be greater or lesser. Number 42. 0.101. All right, this is getting tricky. So let's, okay, now watch this. 0.10 and 0.11. There you go. I've gone, or watch, what if I said 101 and 110? Whether I say 10 and 11 over 100, or 101 and 110 over 1,000, what's going to be the connector here? Less than, greater than, or equal to? Is 101 less than, greater than, or equal to 110? Less than. Everybody follow that? Thank you. 44. Oh, you're not going to like this one. This one's going to make somebody mad, or else give them a headache. 0.333 ... plus 0.666 ... adds up to 0.999 ... Agreed? Now, is that less than, greater than, or equal to 1? You're not going to like this. Let's let 10n be 9.999. Then 1n would be 0.999 ... Agreed? Let's subtract those two. 9n and equals 9. So we divide by 9. Divide by 9. And what does n equal? 1. Oh, how disgusting. If you take 0.999 to infinity, what does it become? 1. So the answer is equals. How cool is that, huh? Number 46. What are we doing here? Oh, we're still doing this. Number 46. 0.112. Here's 112. Here's 111. So what do I say? The first one is greater than, less than, or equal to? Greater than. I mean, go out another place. 1122 is greater than 1112, isn't it? 112 is more than 111. 1122 is more than 1112. You don't have to look at all the places. You just go far enough to see enough to say which one is greater or lesser or equal. Number 48. What are we doing here? Find a rational number between 0.28 and 0.285. Now watch what I'm going to do to find this rational number. I'm going to add a 0 here to make them the same length. So now I have 280 and I have 280 over 1,000, and I have 285 over 1,000. Everybody follow what I'm doing? Making fractions out of them? Now, pick a number between 280 and 285. 280 what? 283. So that could be your answer. Somebody else pick another one. Between 280 and 285. 281. So her answer would be 0.283. Your answer would be 0.281. Can anyone find another answer that would be correct? You go, I don't like this one. Math is always supposed to have one correct answer, not 3 or 4 or 5 or more. So when you grade this one in the back of the book, it will say numerous possible answers. Questions? Number 50. Now, number 50 says, this is why you have to read them carefully. Number 50 says, find an irrational number between these two numbers. Same two numbers. So, let's see. Someone give me a rational number to write up here for number 48 between 0.280 and 0.285. Someone just give me one. I mean, I know you gave me some choices that you're putting down, but someone just give me one real quick to write down here. 0.28 what? Someone just say something. 4. Thank you. Okay, so 0.284 is a rational number. Now, how would I take 0.284 and make it an irrational number? Watch this. 0.284. 1, 2, 3, 4, 5, 6, ... You follow what I did? I just stuck a bunch of junk on there and put 3 dots to say it doesn't terminate. And I just made it an irrational number. Everybody follow the process? You like this? No, you don't like this. Questions? Let's do number 52. Now, you don't have to use the same number, but you understand, I just was using it for comparison's sake, so you could see the relationship between finding a rational number between two numbers and an irrational number between two given numbers. Number 52. What am I supposed to do? Don't you love it? We can make a rhyme anytime. Find a rational number between 0.303003000 ... There it is. And I want a rational number between this number and this other number. Okay, watch. 0.303, 0.304. Well, that's not going to help me. Let's go to 0.3030 and 3040. Now I've got a lot of choices, don't I? I have 0.3031, 0.3032. You follow me? 0.3033. I could go clear up to 0.3039, couldn't I? But they want a rational number, so I just take one of these and let it terminate, and I just found a rational number. Okay? Clear up to 0.3039. And then there's a whole bunch between 0.3031 and 0.3032. There'd be 0.30311, 0.30312, up to 0.30319. Isn't this fun, how far we can go into the woods? No. Okay, let's do number 54. Now I want to find an irrational number between these two. So pick one of these rational numbers that we got, because it's the same numbers again, and let's pick an irrational number. Pick one of those. Someone give me a rational number between those two.
0.3032.
0.3033. And that's rational. And how do I make it irrational?
Add a bunch of stuff up.
Just add a bunch of stuff and put 3 dots on it. 5, 6, 2, 1, 7, 4. Just add a bunch of stuff and put 3 dots on it. You follow me? But could you just put 3, 3, 3, 3, 3, 3, dot, dot, dot? If you saw all those 3s, what would it look like repeats? So you want to make sure you're not showing a pattern that would look like it repeats. And that's an irrational number for sure. All right, number 56. A rational number between 7/9 and 9/11. Well, I go 9 times 11. So this is times 11, this is times 11, and I have 77 of these, and 9 times this, and 9 times this, and I have 81 of these. So where's a number between 77 and 81? Someone give me one.
79.
79. And then I make a fraction line, and that's over 99. Everybody follow that? 9 times 11. And there you go. I just made a fraction between those two. And it's rational. Now, look at 58. Find an irrational number between 2/11 and 3/11. Well, watch. 2/11 would be the square root of 4 over 11, right? 2 is the square root of 4. And the square root of 9 would be the same as 3. Everybody follow what's going on? Why am I wanting these radicals? I want an irrational number. So now, what could I put over 11 right here in the middle that would be between these two but would be irrational?
Square root of 5.
Excellent. The square root of 5, the square root of 6, the square root of 7. You follow? There's a whole bunch of them. Now I'm learning I can use these square root symbols or this radical sign to label irrational numbers. Now, I suppose what you could do is you could take 11. Let's just go back to black ink here and do that. What's 2 divided by 11? 2 divided by 11 is, oh, did I do that one down here? Yeah. 2 divided by 11 is 0.18, and the 8 repeats. 3 divided by 11, well, let's go back to red. 3 divided by 11 is 0.27, and the 27 repeats. So find an irrational number between 0.18 and 0.27. 0.19, and then just a whole bunch of stuff with 3 dots. You follow me? Or 0.20, and then a bunch of stuff with 3 dots. So there's a couple of ways to get an irrational number if you don't like using radicals, but I just think those radicals are so cool. Number 60. Find a rational number between 0.1 and 0.1111 dot 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 dot. So this one, I add a couple of zeros, so I've got 0.100, and this one is 0.111, and it keeps going. But now I've got 100 and 111. So give me a number in between. .105. You see that? Or no, that one doesn't work. That one doesn't work. What would be another one? 0.10. Yeah, as long as I'm 0.109. 0.107. I don't know why I had that stuff written down there. Let's just erase those. Get them off of there. You follow what's going on? And they want it rational, so I let it terminate. Number 62. List these numbers from the smallest to the largest. So how do I compare these? Watch what I do here. I keep adding zeros to make them all the same length. So now I have them all going out 4 places. Nope. Let's do one more. Everybody see that? This one's out 5 places. 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 Everybody follow that? Now look at the red lines I've made. Which one of these numbers, looking at the 5 digits, which one is smaller? Is this the smallest one? A. List them from smallest to largest. So which one's the next smallest after 10000? 14000? Everybody see that? That's the next one. Then what's the next one after 14000? 14100? Everybody see that? And then what's the next one? 14140 or 14141? That, and then E, that's the largest. Okay? You see what you do? You just annex zeros is what they call it. So you make all the numbers the same length. And that would be tens, hundreds, thousands, 10,000s. So that's 14,000 hundred thousandths. That's 14,140 hundred thousandths. That's 14,141 hundred thousandths. That's 14,100 hundred thousandths, and that's 10,000 hundred thousandths. You see how you're making the numerators the same length, so you're comparing identical things. Questions? 64. What does 64 want me to do? It says the Fermi National Accelerator Laboratory has a circular atom smasher that's 6,562 feet in diameter. So this is the diameter of this atom smasher. And what do they want me to do? Find the distance around in miles. Well, how would I find the distance around this thing? What is that distance called? Circumference. Do all of you know the formula for circumference? Circumference equals pi times the diameter. Well, the diameter is 6,562 3.1462 feet. And what's pi? 3.14. Did we work that out somewhere? I didn't work it. What's that all about? What's 3.14 times 6562? You're probably not going to tell me. 3.14 times 6562 equals 20,604.68 feet. 20,604.68 feet. So how many miles would that be? Divide this number by what? 1 mile is 5,280, so divide this by 5,280. So I take this number and hit divide by 5,280 equals 3.9 approximately. 3.9024015 is what my screen says. So I suppose if you wanted to go to 3 decimal places, it'd be 3.90 if you were using your rules from the previous topic. Questions? Number 66. The smallest functional phonograph record is a rendition of God Save the King, which is 1 3/8 inches in diameter. The diameter is 1 3/8 inches. Find the circumference. So that would be circumference equals 3.14 times, what's 3 divided by 8? 0.375 times 1.375. Multiply those two. 1.375 times 3.14 equals 4.3175. 4.3175. And they want that answer to the nearest hundredth. So here's tenths, here's the hundredths. So I look at this one and say it's going to be 4.32 is going to be my answer. Okay? Yeah, that's what I did down here. Why did I do that? Stop when you get to 67. That's your last problem. What did I do? Was that? Oh, 66. No, I didn't do 68. Why didn't I do 68? Huh. I don't know. Didn't do it, so. But I say stop when you get to 67, so I guess I just didn't get around to doing 68. That's too bad. That looks like a fun problem. All right. I'll be around afterwards to answer questions.